Okay, so if we take a look, like I said, we're not going to probably get through this entire thing today, but where we were at compared to where we're at now, the first half to 2/3 of the chapter was all about solving those different types of equations. Linear ones that had fractions in them, rational equations, all the different quadratic type of equations, where we did quadratic formula, all the factoring, all that kind of stuff. We did absolute value equations. And now the second part of this chapter was all about the inequalities of those same things. So pretty much the only two parts that we haven't talked about yet is what about polynomial inequalities, kind of the quadratic ones, and what about rational ones? We're not going to get to the rational ones today. We'll save that for tomorrow and finish that up. But we can take a look at the polynomial ones, okay? And so here's the process again. Okay, the process is pretty much exactly the same as what you were just doing with the absolute value inequalities, where once again, kind of 1 and 2 are going to go together. You're going to find all the zeros, all the critical points. Okay? The critical points with a polynomial is when it equals 0. So you want to set the equation equal to 0 and solve. And again, that's going to take you right back to factoring, quadratic formula, all that, all of those types of things. Greatest common factors. So even though I have them listed as 2 steps, it's really kind of one concept. Find the zeros, which are the critical points. Then again, like I said yesterday, 3 and 4 kind of go together as well. Then once you have those critical points, we're going to put them on a number line and kind of test out the regions to see where do I have true versus false statements. And same thing as yesterday, put your final answer in interval notation. Okay. So the problems will be different, but the process will be similar. And one of the nice parts about the very first part here is we're going from an inequality to an equation, so I don't have to worry about kind of the inequality parts of it. Then I'll go back when I start testing things out. Then I'll go back to the inequality. So that's the part where we're going to make it simpler for a little while, and then we'll go back and take a look at the inequality portion at the end. Okay, so example number 1. Here's your first example. It's an inequality, so it fits with what we've been doing, but now it's a quadratic inequality. So this one's already equal to 0, if you will. Okay, so I'm going to just go straight and turn this into an equation so I don't have to worry about the inequality right now. So we've got x minus 3, that quantity squared, minus 1 equal to 0. And we solve like we did a week ago. What's step number 1? What do I do first here? Add the 1. Yep, let's get the squared part by itself. So we've got x minus 3 squared equal to 1. Now what? What do you do? Now we unsquare. We take the square root. Okay? Now we get rid of the squared. We take the square root of both sides. Okay. So that unsquares the left-hand side, leaving you with x minus 3. And on the right-hand side, what do I have to remember? Plus or minus, because we're taking the square root in an equation. And the square root of 1 is 1. And now we finish it off to find our critical points. Add the 3 over. If I'm using the positive one, 3 plus 1 gives you 4. There's 1 critical point. 3 minus 1 gives you 2. There's your other critical point. So those are the 2 values. I call them critical points, but remember what they actually are in this scenario. They're the zeros. We said I'm looking for where is this greater than or equal to 0? Well, there's where it's equal to 0 right there. So in the end, when we start writing our interval, I bring it up, because I know I'm going to include those values in the interval because it's where they equal 0. Okay, so those we're going to have some brackets in our final interval. Now we go to what we were doing yesterday. Now we go to the actual number line and interval notation and all that kind of stuff. So let's put those in there. We've got 2. We've got 4. And we test the different regions. We pick numbers from each region. We plug it back into the original problem. And we see, do I get a true statement? So for example, let's pick like 0 here for the first one, for the first region of numbers. If I plug 0 in, 0 minus 3 is negative 3. Negative 3 squared is 9. 9 minus 1 is 8. Is 8 greater than or equal to 0? Yep, true statement. There's your first interval right there. That's going to be part of our final answer. Then we test out the middle portion. If I pick 3 and plug it in, we get 0 squared is 0, minus 1 is negative 1. Negative 1 is not greater than or equal to 0. Therefore, that gives you a false statement and therefore is not going to be part of your final answer. And last one, anything bigger than 4. Let's say I pick 5. Plug it back in. You end up with 2 squared is 4. 4 minus 1 is 3. And 3 is greater than or equal to 0. Therefore, you end up with 2 separate intervals that will, when you plug numbers in, will give you a true statement in your original inequality. Okay? So now the last thing we need to do then is use that number line to write our final answer, our interval. So first one, where am I starting? Negative infinity up to 2. Not including negative infinity again, because it's not a number. But remember we said, the original problem said less than or equal to 0. And 2 is where it equals 0, so I am going to include 2. There's your first interval. But I have a second one, so we got to put the union in there. Or, starting at 4, once again including that number, and going to infinity. So any number in either one of these intervals will satisfy that original quadratic inequality. Like I said, I'm hoping you notice pretty quickly that most of this is what you've been doing. That's why yesterday when I told you that there's multiple ways to solve those absolute value ones, and I said the way that I picked is a way that we could keep using in the future, that's why I taught yesterday the way I taught it, knowing that this was coming next. Okay, so you could still use the concepts. Let me give you one more. What time are we out of here? 57, is that right? Okay. Yeah, we got time for one more. So once again, here's a polynomial. I'm going to set it equal to 0 right away so that we can solve. And if we solve that, what am I going to do? What's step number 1? Greatest common factor. Yep, I've got an x to the 4th in each of those two terms. So let's pull that out. I end up with x minus 3 left in parentheses. And remember, whenever we get something equal to 0 and we factor, the whole point of that is 0 product property. You can't do the 0 product property if it doesn't equal 0. But now I can set each factor equal to 0. So x to the 4th, I set that equal to 0. Take the 4th root, and we end up with x equals 0. Let's see if you remember real quickly, because this is going to come back. Remember back to Algebra 2 last year when you talked about like double roots and single roots and all that kind of stuff? Where if it goes through the x-axis, it was a single root. Sometimes when it's a double root, it would come up and touch the x-axis and then go back down. Remember doing that? That's going to come into play here, okay? Because we have a 4th root. I only bring that up because we'll talk about it in the end so you can see, so you understand the answer. The other, if we set the other factor equal to 0, I get x equals 3. There's your 2 critical points right there. There's where this inequality would equal 0. And once again, we're going to include those in our final answer because of the fact that it's less than or equal to. All right, let's put the number line out here. And let's test our first section here. And then I'll ask you a question. So let's say we pick some negative number. I'm going to pick -1. What's -1 to the 5th? -1, because it's to an odd power. -1 to the 4th will be 1 times the -3 that's already there. We get -1 minus 3, -4. Is that less than or equal to 0? Yeah. So, true statement. We found our first interval that's going into our answer. Now, quick question. What do you expect to come next?
False.
And then? Probably, based on what you've been doing, probably true, false, true, right? So therefore, it's kind of an or type of an inequality. Okay. Or the other option would be false, true, false a lot of times. And that's an and type of inequality. There are exceptions to the rule. So just because you see the first one is true, you can't just automatically keep going. You have to still test. For example, let's take 1 and plug it in. 1 to the 5th is 1. When I plug in 1 here, it's going to be a -3. 1 minus 3 is -2. Is -2 less than or equal to 0? Notice, I have a second true interval. Okay? Not false. So you do have to test it. It doesn't happen super often, but it does happen. And then, I'm going to kind of just skip to this because we're getting a little bit short on time. If you plug in something bigger than 3, what's going to happen is you're going to end up with a false statement here. So it actually turns out true, true, false. Okay? So here's the idea. When we write our interval now, I actually have an interval here, an interval there, and remember we are including 0. Yeah, Aiden, question?
If it was true, 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 would it be all real numbers?
If it was true, 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 it would be all real numbers. Yep. If this was all true, plus we're including the critical points, it would be all real numbers, and your interval would be -infinity to infinity. Okay? This one, however, we're going from, don't pack up yet. We got a few minutes. We got like 4 or 5 minutes yet. I'm going to need the 4 or 5 minutes today. In this case, we're going from -infinity. Normally we would say to 0, but I'm including 0, and we keep going. So I can actually look at this as one whole interval, from -infinity to 3, okay, including that. Hang on. We're not there yet, I promise. I'll tell you when we're there. We're not there yet. So the next question that I have for you then is, somebody in one of the other classes said, well, what if that 0, what if we weren't including it, and we had true, true, false? I'm going to write it down. You can write it down if you want to, but just so you understand it. If I had this interval and that interval, but not 0, here's what you would write. You would go -infinity to 0, not including that, union 0 to 3, not including 0. If you notice this interval compared to the actual final answer, it's the same thing if you put it together, with the exception of what? One number.
0.
Just not including the 0. So if that wasn't less than or equal to, it was just less than, that's how you would eliminate only the 0 out of there. Last thing. Then I'm done. I told you before, remember like the double root, single root kind of stuff? This is the reason why this is true, true, and we're looking at negative numbers. This graph is below the x-axis, comes up, it touches right at the origin and then goes back down. That's why you have true and true on both sides, and why it didn't change from true to false. It comes up and your graph would look something like up here, and then it goes back down and still is negative. It didn't change signs from positive to negative. That's what's going on. That's why I brought that up earlier. Okay? Let me get you your assignment here quick, and I'll tell you which parts I want you to do.